Hello, how are you doing? This is Mike here, and this is a continuation of our last video. So if you did not get a chance to watch the last video, it's a video where we described the multiplicity algebraically of a zero. This video is going to discuss what the multiplicity indicates graphically. So we're going to expand upon what we learned in the last video and discuss what this really means, what a multiplicity really means. So let's go ahead and look at some basic graphs. I always like to look at some basic graphs. Let us say we said we had the graph f of x equals to x minus 2 squared. We looked at this last video. And x minus 2 squared is a graph that is a parabola shifted to the right. So some of you that may recognize the transformation here is shifted to the right and it opens up. And remember, it has that horizontal transformation because it has that negative 2 value. So it's been shifted to the right. So notice here at x equals to 2, the graph is strictly tangential. It touches the value 2, it touches the x-axis, and then it bounces off. It doesn't cross it. Let's look at an example here of f of x equals to x minus, let's look at x minus, let's say x plus 2 cubed. So this example is going to be a cubic function. It's going to be that cubic function, but it's going to be shifted to the left 2. And if we look at our transformation again, we realize that we have a positive 2 here. That's a positive 2. Make sure we can see that positive. So that's a positive 2. So we're going to shift to the left 2 values, but this is a cubic. It's a cubic because we have a third degree there. So we're going to start down there at negative infinity in quadrant 3. We're going to touch, and then we're going to continue off like such. It's going to look something like that. This is not a perfect indication. However, what I want to emphasize here is what's going on at these zeros. So notice here at this 0, I call this tangential. Tangential or tangent means we just touch and bounce off. Tangent means to the point. Someone that's very tangential in personality, they tend to be very to the point, not a lot of conversational pieces that don't relate directly to the topic. They are very to the point. This, however, at this 0, notice here at this 0 at negative 2, we actually cross the x-axis. We cross the x-axis. So at this 0, we are just tangential. This we cross. One is tangent, the other one's cross. And that's actually the directive that we're going to take for the multiplicity. Notice here my multiplicity is a value of 2. Tangent, even, tangent, even, tangent. Notice here my multiplicity is a value of odd. Odd, cross, odd, cross, odd, cross. Let's go ahead now and surmise, or maybe this might help make the rules a little bit more easily understood. So the multiplicity rules. So we state, this is more mathy. I'm going to call this more mathy. So if x minus c raised to the k power is a 0 of a polynomial, and x minus c to the k plus 1 is not a 0. Not a 0. So I'm just going to go ahead and explain what this means. I always think it's important to explain the math. So let's go ahead and say if, let's just say we have x minus 3 squared. And this is a 0. This is a 0 of the polynomial. What this states is that the next power, k plus 1, notice the k here is a value of 2. It states that if you aren't accounting for another 0 or another term, you have to make sure to do so. So for example, if we combine or multiply these x minus 3's together, this would give us x minus 3 cubed. So notice 2 plus 1 gives us a value of 3. So they're just making sure in the directions that you combine all the terms. So we will call k, so k will denote the multiplicity of that 0. If k is odd, the graph will cross at the 0. And normally they say the 0 at x equals to c, so I guess I could include that. So the 0 x equals to c. So for example here, we would solve, we get x equals to c. And if k is even, the graph will touch at the 0, x equals to c. So we want to recognize that if k, the multiplicity, is odd, right? K is the multiplicity. If k is odd, the graph will cross. The graph will cross. If k is even, the graph will simply touch at that 0. So let's go ahead and combine this all. We're going to combine leading term analysis and multiplicity all into one. So let's go ahead and look at an example. Let's go ahead and look at an example. Let us say we said f of x equals to x plus 2 squared times x minus 3 cubed. So if we examine this, we recognize that if we want to find the zeros, we're going to set x plus 2 squared equal to 0, and then we set x minus 3 cubed equal to 0. And according to my definition, this 2 and this 3 are the values that indicate the multiplicity of the zeros. Solving here, we're going to get x equals to negative 2. And this will have a multiplicity equal to 2, which is an even value. So if we have a multiplicity that is even, our graph will solely touch. So I always like to call this next part, I always like to say action. The action of the graph. And the action here is to touch. So in this next circumstance, when we solve this, we're going to get x equals to positive 3. However, his multiplicity, or this multiplicity, is equal to a value of 3, and this is an odd value, and this is an odd multiplicity. Therefore, if we have an odd multiplicity, we know that we're simply going to cross. We're simply going to cross at that value. So in one circumstance, we're going to cross at the 0 when we have an odd multiplicity. In the other circumstance, we're simply going to touch when we have an even multiplicity.